Hello, algebra students. We're going to work on some exponential growth and decay problems today. So I'm going to share my screen and start the presentation. You're going to want to grab a piece of paper to start today's warm-up. I'll get this rolling. So the warm-up is the kind of problems we did last time. It says the table represents the number of customers at a new bookstore after 8 weeks. Write an exponential function that represents the number of customers. Go ahead and pause the video and give this a try. All right, welcome back. Let's see how you did. I'm going to grab my pen here. So remember, we have to start by using the form y equals ab to the x. All right, again, here our a is our initial amount at time 0, which in this case, time 0, we have 20 customers, right off the start. Then we have to look at our growth rate. What are we multiplying each of these y values by? It looks like we are multiplying by 2. 40 times 2 is 80. 80 times 2 is 160, and so forth. So our growth factor is 2, and we put a to the x power. All right, let's look at today's content. We have a bunch of vocabulary to write down. The vocabulary terms are on page 185 in your journal. All right, exponential growth is when a quantity increases by the same factor over equal intervals of time. This is what the growth function looks like. Notice you are adding a rate. This is usually a percent written as a decimal, and it's 1 plus that. Oh, let me go back here. Whoa, really got carried away. Decay is when a quantity decreases by the same factor over time. Notice we are subtracting 1 when it's a decay factor. Compound interest is the interest earned on the principal or the initial amount and on previously earned interest. So if you put money in a savings account that earns interest, each time they calculate the amount of money in your savings account, it's your initial amount plus the interest you earned, and then you earn interest on your initial amount and the interest, and that's called compound interest. All right, let's jump into some extra practice on page 187. It says in 2005, there were 100 rabbits in Polygon Park. The population increased by 11% per year. Write an exponential growth function that represents the population t years after 2005. If you don't have a calculator handy, you're going to want to grab one right now because lots of these, well, somehow I lost my pens here big time. There we go. Come back. All right, grab my pen. Okay, so we need to write a model, all right? And our model, it says it's going to look like y equals our a value, right? Our initial is 100 rabbits. That's our initial amount. It says the rate of growth is 11% each year. So it's growing, right? Rate of growth. It's increasing here, right? So it's going to be 1 plus our 11%. To write 11% as a decimal, it's 0.11. And it is t years after 2005. So 2005 is our initial year. What will the rabbit population be in 2025? Round your answer to the nearest whole number. All right, so we're going to write down y equals, we still keep our 100. We still keep our 1 plus 0.11, which turns into 1.11. And now we need to calculate the time. Well, we started in 2005 and it goes to 2025. So the number of years that has passed between 2005 and 2025 is 20. All right, so grab your calculator. Remember, you have to do the exponent first. Most calculators will allow you to enter this all in one step. So that's what I'm going to do. I'm going to type into my calculator 100. I'm going to go ahead and put my parentheses. I put my 1.11, and your calculators have the same capability to do an exponent of 20 on your calculator. So here's what I've typed in. My calculator keystrokes are 100. I did my left parentheses. I typed in my 11. To do an exponent of 20, you're going to push the little key that looks like this. It looks like a little caret, as we call it. You're going to push that key, and then you're going to enter your exponential value, your 20. So then I'm going to do that, and that goes outside my parentheses. I enter to the 20th power, and I get that they're about, and it says round your answer to the nearest whole number, right? We don't want any partial rabbits. So we have 806 rabbits. All right, so in 20 years, the rabbit population grew from 100 to 806. All right, let's look at our next one. This time it's just asking, was it growth or decay? So these are extra practice problems. You can find them on page 187 in your journal. You're looking, first of all, remember this is just your initial amount. You're looking in that parentheses and you're seeing, is it a number greater than 1 or a number less than 1? If it's a number less than 1, it's decay. And you just have to figure out how far off of 1 are you to get your percent of change. So if I look at 0.95, if I have 95 cents, I don't have a dollar, right? It's less than it. So this represents decay. And to find my decay factor, I can subtract 0.95 from 1. And I'm going to get 0.05. So what is the percent of change? It is a 5% rate of change, right? It's a decrease, right? It's decreasing by that amount because it's exponential decay. All right, let's look at our next one. This time I look in the parentheses. 1.08 is greater than 1, so this represents growth. The question is, how much bigger than 1 is it? Well, let's see. 1.08 minus 1. I'm doing the bigger minus the smaller. This time I get 0.08, which would be 8% growth. All right. This next one, they wrote it in fraction form, but that's okay. 3/4 is still less than 1. 3/4 written as, or I could do it this way. Let's go, we know it's decay, right? Because this is less than 1. So I'm going to subtract 3/4 from 1. That leaves me with 1/4. To write that as a decimal, I do 1 divided by 4, or most of you probably know, 1/4 of a dollar is 0.25 or 25 cents. So this is a decay factor of 25%. All right, let's look at our next slide. This time we're working with compound interest. That's what I talked about earlier. If you put money in the bank. I'm going to grab a, well, I guess it's on blue, so that's good. All right, so some things here. Y is the amount you're going to have at the end. P is, we call it the principal. It's the amount you put into the bank to start with. We have our 1, just like we had before. It's going to be growing, we hope. R is your interest rate, written as a decimal. N is the number of times the interest is compounded per year. It could be compounded monthly. It could be compounded quarterly. It could be compounded annually. It could be compounded continuously. So number of times it's compounded per year. That N is the same as this N here. You write it in 2 places. And T is your time in years. All right, let's look at some problems dealing with compound interest. So the first one, it says we have $3,000 deposit that earns 6% annual interest compounded quarterly. When you see quarterly, that means 4 times per year. It takes a year and divides it into quarters, right? There'd be 4 quarters. So it's compounded 4 times a year. So I'm going to use my compound interest formula. Again, is Y equals A times 1 plus R over N to the NT. And I'm going to fill in all the numbers. All right, we want to know how much do you have after this, right? You're depositing $3,000 to start with. You have 1 plus, your interest rate is 0.06. Remember, we write the interest as a decimal. The number of times it's compounded, we said was 4. And this is going to be 4 times. And do they give us a time here? Nope, they just want us to write what it would look like. So 4t, okay? We don't know how many times it's going to be compounded, okay? Or excuse me, don't know how many years it's going to be done. But if I wanted to, I could just replace this t and I'd find out how much money I had. All right, let's do the same thing here on number 10. This time we're depositing $5,000. We have 1 plus, got to do our interest rate. Remember to do your percent to change it to a decimal. You're moving that decimal point 2 places to the left, right? Just like 6% was 0.06, right? So 7.2% is 0.072. This time it's compounded monthly. How many months are there in a year? There are 12, so this turns into a 12. And our exponent is 12 times t, where t is the number of years, and we don't know what that is. They haven't asked us to calculate it. They're just asking us to write the equation. All right, let's look at our next slide. It's our assignment, okay? 6.4 is divided into 2 parts of this lesson. We're just doing part 1 today. The link to the textbook pages is on your agenda, so you can find that link and complete these problems. If you have any questions, you can just email me. Good luck.